Thanks for joining today's webinar, Getting It Right, OpenStack Private Cloud Storage. We're looking forward to this discussion, and we'd like it to be as interactive as possible, so please feel free to submit any questions you have at any point through the Ask a Question button, and that's right above your presentation window. We'll try to get to all of them, but if we run out of time, we'll be sure and get an answer to you shortly afterwards, so just keep that in mind. And a couple of other housekeeping items before we get started. The presentation slides are available for you to download in the attachments folder. It's in the right column of your console there. And then you'll also find a couple of additional resources there on the topic of OpenStack storage. So be sure and take a look and download those when you have a chance. And with that, I'll go ahead and introduce today's presenter, Aaron Delp, Cloud Solutions Architect at SolidFire.
Hey everybody, this is Aaron. So first of all, thank you, Jen. Good morning, good afternoon, good evening, wherever you are in the world, or whether or not you're catching this either live or on the replay. I wanted to say thank you very much for taking some time out today. What we want to talk about is OpenStack and building private clouds with SolidFire storage as well. And as far as an agenda goes for today, we want to kind of start very high level with why OpenStack and how did OpenStack kind of come to be, but it's going to be a quick introduction. And from there, we're going to move down a little bit into the specifics of OpenStack storage, and then Cinder block storage, if you're familiar with that terminology and that name. And then we're going to dig into why SolidFire. What are the benefits of running Cinder block storage in OpenStack with SolidFire? And we'll be taking questions throughout. So as Jen mentioned, please go ahead and submit questions in the chat or in the actual submit questions section. And then we will be getting to those either throughout the presentation, or we'll certainly get to most of them at the end as well. And with that, let's get started here. A little bit of why OpenStack. Well, it's a little bit of history to really talk about why OpenStack. And it really goes back, honestly, almost 10 years now, maybe even further. There was really this concept of virtualization in the market. And what was virtualization? Virtualization was taking physical hardware bits, whether it's compute, CPU, memory, network or storage, and really abstracting away the physical environment into a virtualized environment. And what we're looking to do there and what the benefits that we achieved there was an efficiency benefit and an abstraction and portability standpoint. Two quick use cases around that were cited a lot in original virtualization was this ability to have multiple virtual machines running on the same physical infrastructure to get greater efficiency and really get a higher utilization out of that architecture. And at the same time, not be very tightly coupled to that underlying hardware infrastructure. And this was great, and this is why we saw this boom in the virtualization industry. But something had to change. And what I mean by that is that was great, but we needed to become more agile. Once we realized we could abstract away this level and decouple the hardware from the software, well, we wanted to be able to do things with it and actually go faster. This infrastructure, while great, was just far too static for most organizations. And this led to OpenStack and really cloud orchestration solutions in general. And what were some of the kind of advantages, if you will, that led to this mass adoption of OpenStack out in the community? Well, again, it's this ability to go faster and innovate. When your underlying infrastructure is abstracted away, you are able to consume it in a completely different way. And through open source software technology, you're allowed to really have this melding of and joining of the users that are out there in the community as well as the vendors that are out there. Prior to open source, the kind of the rise of open source software and cloud computing, it was a very vendor-driven ecosystem where the users just consumed the software, but they didn't necessarily have any say into the direction of the product. And that is very different in open source software. And that is why it has become so predominantly popular in cloud architectures going forward. And in addition to that, there was a cost savings and this ability to avoid vendor lock-in because you're abstracting away the underlying vendor hardware. Now, it is up to each of the hardware vendors to really provide some benefits and some advantages to their particular products in an open source environment. And that is what we're going to actually cover today, of how does the benefits of SolidFire and OpenStack, well, how is that such a key differentiator for you going forward? Now, talk about OpenStack for a second. If I go a little bit deeper into OpenStack storage, well, there's actually a couple different ideas in this. So first of all, there's a couple different types of storage, which I'm going to cover on the next slide. But before we even go there, there's decisions to make and there's choices to make. And this is probably the hardest part of all of this, because there are many storage solutions out there, and they each have their own merits. And they have their own special use cases where they will excel at. And so if you already have your own gear on site, there may be a specific use case for that. But you may be looking to re-architect your storage in OpenStack. And some of the questions that we ask customers when we have these conversations are listed there of, does this scale? Is this architecture a good fit? Is this kind of a test development environment where I'm just kicking the tires? It's not necessarily production. It's not necessarily, even medium to large scale. What kind of support will I expect from this? What kind of performance will I expect to achieve the more workloads you put on there and the higher value those workloads? Well, you probably need a greater amount of performance, and you probably have, the more workloads you consolidate, what we like to call a noisy neighbor scenario, and I'm going to go into that more in a little bit. But really it comes down to workloads matter. What is the workload that you will be using on top of OpenStack? And that will be probably the single point that will answer all of these questions for you. How important is the workload, and how well do you have to run it? And that leads us into the different types of storage. There are many different types of storage within OpenStack, and each of them has, reasons and use cases to deploy them. And I'll go over each of these quickly, and then I'm going to go on the next slide a deep dive into two in particular. The first one in the top left is what we call ephemeral storage. And ephemeral, the easiest way to talk about it is call it non-persistent. When you power off a virtual machine or an instance with an OpenStack, it goes away. And so the life cycle coincides with the instance. The storage only lives as long as that instance is there. So it isn't good for anything where you need persistent data, but it's great for certain use cases where you're spinning up a number of nodes in a workload. They live for a certain amount of time, they do a certain job, and then they go away. And because of that, we usually tend to use local file system storage for something like that. The next one is object. Object storage is mainly known as the Swift project within OpenStack. Each of the OpenStack projects has a name if you're unfamiliar with that. And this is the Swift project. And typically what we like to think of it as cheap and deep kind of storage. And I'll go into more on the next slide about that. The next one that is kind of up and coming is what we refer to as Manila, Project Manila, and that is really NFS storage. And then the one on the right is block storage, and block storage is where we tend to see most of our customers these days. And we think of block storage as very foundational. Think of it as it is a raw disk type. It is, in older terminology, it is a SAN disk, if you will. And typically higher performance, persistent workloads. And then the OpenStack project that goes along with that is called Cinder, because the joke being there is Cinder block storage. And if I compare and contrast both Cinder and Swift for a second, block storage versus object storage, well, what's interesting here is it isn't necessarily one versus the other and you're using one or you're using the other type. This is really an and scenario. And what I mean by that is they're very complementary. And many of our customers use both of them together. And it just, again, depends on the workloads. Workloads and use case requirements drive needs in OpenStack. And so if I go look on the left-hand side at the Cinder block storage for a little bit here, this is persistent storage that is typically performance-sensitive applications. And if you're familiar with Amazon, a lot of people like to refer to things in Amazon services, Amazon EBS, or Elastic Block Storage-like service. And the use cases around there, this is typically, you will run your production applications, your database systems, your test dev systems, where you have a high rate of change, either within the data or within the workloads themselves. Maybe we're creating workloads, using them for a certain amount of time, and then they go away because they're no longer needed. So a lot of small, random reads and writes, and what we refer to as bursty I/O or bursty workloads. And on the right-hand side, this complements it very well. Well, what do you do when you have workloads that don't require that? Because there are certainly OpenStack workloads out there that do not require this. And so what do we need to do when we talk Swift? Well, we refer to that as lower cost scale-out storage, a lot of times spoken to directly through an API, and a lot of backup, archiving, data retention, static content, if you will, as opposed to high change content. So VM templates, ISO images, backup and archive, repository, static web page images. There's a lot of use cases out there where it's larger sequential reads and writes, or it is a lower IOPS or input-outputs kind of scenario. And the two of them together cover a lot of the storage needs within OpenStack very well. Now, to be clear, today, SolidFire covers the left-hand side, the Cinder block storage. And so we want to talk about that a little bit further. We want to go a little deeper into what is OpenStack Cinder block storage. And so we'll go there next, and we'll start off with some Cinder basics. And then once we understand those... Go ahead.
Had an audience question come in.
Go ahead.
Do you have a moment to take that? They're just asking, what about Seth? When would I use Seth?
Oh, fantastic question. If I go back here real quickly, too, there is honestly really almost like a third type of storage within OpenStack specifically. That is Ceph storage. Ceph uses its own protocol, but underlying storage of it is basically object. They do file level Cinder abstraction, but we have joint customers out there, and our joint customers really have used the Cinder block storage where they need the performance guarantees and the high performance workloads of Cinder. They will use us, and then they will use Ceph, very complementary, for that right-hand side, for that object storage. And we actually have the ability to back up from SolidFire to Cinder or to the object storage. And so we see a lot of, again, you can almost think of it as SolidFire on the left and Ceph on the right in this instance. Great question. So now what I'll do is I'll dig into some Cinder basics. And we've got a mission statement here, and this is the mission statement of the OpenStack Cinder project. To implement services and libraries to provide on-demand self-service access to block storage resources. That's a mouthful, And there's an even bigger mouthful at the bottom. I'm not going to read that one to you, but here's the easiest way to think about Cinder. Think about Cinder as a USB thumb drive or flash drive. It is persistent storage, and if you have, you're holding a flash drive in your hand, you can plug it into a laptop or a desktop computer. And what happens when you plug that in, it is mounted to that machine, or in an OpenStack context, that instance, and it is mounted as a drive that is usable, and it is persistent, so you can copy files to it, and then unmount it or detach it, and then it will persist, it won't go away, and then you could mount it back later on to that same instance or machine, or you could mount it to another instance or machine, just like you could copy a file on a flash drive and then hand it to somebody else, and then they could copy it onto their laptop. So think of the many use cases there of I can attach storage. It isn't tightly coupled to the instance. I can attach it as needed, copy things as needed, detach it and store it. I can move it somewhere else. It basically allows us to decouple storage from the instance and allow us to use it as needed and then store it as needed as well. That is the best analogy I have with when folks want to get started in exactly what we're talking about when we talk block storage or Cinder storage. And why would we want to do that? Well, the main goal, getting back to that why virtualization wasn't enough, is OpenStack really gives us the ability to kind of automate everything. And what I mean by that is OpenStack has this ability to provide on-demand resources, and not just storage. Let me be clear there. The whole idea of cloud computing at a higher level is taking physical resources in the data center and carving them up into dynamic pools that can be allocated as needed. And so if I have pools of compute, pools of memory, pools of networking, and pools of storage, whether it's storage capacity or performance, and I can give those out to an application, to a tenant, and they are used for a certain amount of time and then handed back. This idea of making things as easy as possible and to make that infrastructure very dynamic and flexible. And that is really the main goal of both OpenStack and the Cinder project specifically. And so if I look at how do we achieve that goal, if I take it down one level further, well, you as the cloud user or the cloud administrator, you basically make a set of what we call REST API calls. This is basically API calls, automated calls, that allows us to do certain tasks within Cinder block storage. For instance, creating a volume, which would be the idea of creating a flash drive or a USB stick in my previous analogy. Attaching it, so plugging it into an instance, deleting it, detaching it. It kind of goes on and on, the different values or different calls that you can make. And it isn't just you need a third-party storage company. You can actually get started in the Cinder project using what they call a reference implementation that is known as LVM. And LVM, you can really get started on any kind of server that has local disks in it. You can connect that up and you run a certain number of services within Cinder, which I'll go into in a second. But once those Cinder services are loaded and pointed at the appropriate devices, you can do LVM. You can do other third-party storage, whether it's SolidFire or others. And what's unique about this, it allows us to have that interface, this standardized interface that coordinates and manages all of the storage services. Cinder provides this abstraction layer that you talk to Cinder, and then it, through a plug-in architecture or driver architecture, will go make the necessary calls to LVM, to SolidFire, to any other third-party storage, and allows you to really achieve a nice mix and match and base your volume types or your storage offerings based off of your application needs. And sometimes it helps folks a little bit to really look at a picture. So let's look at a picture here. Now, what we have here is it's kind of a big green blob box on the screen. Think of that as Cinder. And you have a client that is exposed to the administrator user on the top, and then those REST API calls that are made in what we talked about earlier. And then you can actually talk to, okay, is there a backup device? Is a main storage device? There's a scheduler and there's a database that kind of handles all of this and keeps everything in sync. Because again, we need a master set of truth, and that is handled in the database, the Cinder database, because this may not be just one storage system. If we have multiple systems or we have multiple nodes, how do you keep those all in sync? Well, that is done through the database. Excuse me. And then there is some services as well. There's the API service, there's the Cinder API service, there's the Cinder scheduler service, and then there is the volume service. The REST API there, the scheduler API there, and the volume manager. And those three services are what you need to talk Cinder. And that allows us to really achieve, through that plug-in architecture, that volume driver, the ability to talk to just about any kind of device that is out there. Now, that gets us into why SolidFire. Because not necessarily every OpenStack driver or plugin is the same. Just because it talks to Cinder doesn't necessarily mean that you have the same functionality. And I'll get to that in a minute, but I kind of have to paint a little bit of picture of what exactly is SolidFire from a block storage standpoint. And then I'll kind of marry that together with OpenStack here in another slide or two. But it's interesting to think about SolidFire in slightly different terms from traditional storage. First of all, it is a scale-out, high-performance storage subsystem. And what I mean by that, first of all, scale-out, let me break that down. It is different from traditional architectures in the fact that most storage systems that are out there on the market today have the idea of a processor or a controller, and typically dual heads. So you have two storage processors in an active-active configuration in case one fails, the other one can take over, but think of it as two brains, if you will. And then those two brains control a bunch of disk shells behind that. And in this instance, OpenStack would talk to those two brains. Well, SolidFire is different in the fact that we are a node-based architecture. You can kind of see there all of the different nodes in a rack, but each node is a brain. And so scale out means this is multi-brains. And what's really nice about that is every time you add a node, you're adding both performance and capacity. And in addition to that, you're able to really get a guarantee against the performance. It's not just adding capacity because you are adding performance with every node. You can guarantee all of those different workloads that you consolidate onto an OpenStack environment. You won't have one workload necessarily stepping on another workload, or one tenant doing something they're not supposed to and stepping on another one, or production getting hit because somebody did something bad in test and development. This idea of guardrails around all of your applications or tenants is a key aspect of why we can scale out and why we say we're designed for large-scale infrastructure. Because if you can't guarantee that performance, you don't want to be doing consolidations. And we also believe we have the most complete enterprise feature set of really any all-flash array that is out there on the market today, through replication features and a lot of other things that I'm not going to go into in this presentation in depth, but a quick introduction to that and why we think we're good. Now, if I go back to OpenStack for a second, why SolidFire and OpenStack orchestration in particular? Well, it goes back to, again, flexibility. that dynamic pools of resources. What we're doing with dynamic pools of resources is we're taking that physical infrastructure and we're breaking it down and we're abstracting it away and allowing to create those pools that we can check in and check out. And the next logical step after you have a flexible infrastructure is an infrastructure that you can control. Because, again, if you don't have an ability to put control around a workload and guarantee performance, what we call kind of a service level agreement. If we have a critical application that there is no way we want performance impacted by anyone else on the system, you need that as a foundational aspect for mixed workloads, which is the next one on the right there. Mixed workloads can be multi-tenancy, it can be multi-application, but if you're going to consolidate workloads and you don't have control, all you're really doing is putting a bunch of workloads together and praying they don't all peak at the same time and potentially impact everyone. And when you combine all of that together, you get the ultimate benefit of time to value. Time to value is very interesting because this is really this idea of API orchestration and automation. This idea of controlling both OpenStack through APIs as well as SolidFire through APIs. And this leads to my conversation earlier about more than just another OpenStack driver. And I said, by the way, I see one or two questions coming in. After this slide, I'll take some time out and answer a couple questions. So I'm not ignoring you by any means. This idea of the driver I was talking about, we're doing more here than just checking boxes. And I believe that is a very, very important distinction with OpenStack and Cinder. The Cinder project started a few years ago, and it actually broke out. For those that know OpenStack project names, there's the compute project called OpenStack Nova, which is one of the original two projects. And the block storage within Nova just, quite frankly, wasn't getting the care and feeding or love and attention that it needs. And so SolidFire and a couple other companies were the ones that really broke out OpenStack Cinder from Nova and incubated that project and brought that project forward so that it could be a first-class citizen. So we were there from the very start, and we were integral with the original design of Cinder. And this whole idea of we want to make OpenStack better. And we've done things in our driver, for instance, that are above and beyond OpenStack drivers that are out there. We will take OpenStack snapshots and take those OpenStack snapshots and turn them into a space-efficient clone on SolidFire storage, for instance. And there's lots of other, especially with the multi-tenancy aspects of SolidFire and the multi-tenancy aspects of OpenStack, we do things very similar, and our architectures complement each other very well to where we are truly multi-tenant storage. And that is part of that, again, guaranteeing performance and guaranteeing workloads. And again, this goes to this message of it's not just about, especially about open source software, it's not just about like commit counts, right? This isn't the idea of whoever commits the most and shows up great in the performance stats for the OpenStack community. This idea of we're trying to make a difference and do things that really matter. And we are contributing not just to our driver, but we are contributing code to make Cinder better. Because at the end of the day, OpenStack really is our passion and has been our passion since day one. And before I go on to the next slide, there was a question here of, I heard a similar tool being developed by EMC Corporation. It's called Viper. Does this mean Viper also works as an OpenStack platform? That's actually a really good question, and one I want to address quickly on there. EMC does have a product out there called Viper. Viper is what would be kind of their software-defined storage product, if you will, and Viper plugs into OpenStack and Viper has an OpenStack driver, but it's different. And it's different in the way I have to kind of talk about drivers for a second here. The Viper one, to my knowledge, takes a little bit more configuration. It allows them to kind of abstract away all of their other storage arrays. But at the end of the day, they do have a driver. Viper is their kind of driver, if you will, into Cinder. But to compare and contrast why I believe the SolidFire Cinder driver is different is it is what we call a native driver. And there's, at last count, there's more all the time, but at last count, 40-something odd Cinder drivers or plugins, different storage companies that interoperate with OpenStack Cinder. Native drivers, there's, last time I checked, 11 or 12 or so. Native driver means it's built into Cinder, again, with that going back to that passion we have in trying to make Cinder better, so that no matter what distribution of OpenStack you choose to use, our driver is in there. And you can actually, there's a configuration file called cinder.conf, which runs on your Cinder nodes, and you actually just modify 4 lines in that, and you basically say, what driver do I want to use? What is the IP address I need to shoot at? What are the admin credentials? And you're in. So we support, our backend configuration is less than a minute, typically. It's as long as it takes you to add 4 lines to a configuration file and restart the service. And that key value proposition, again, being you're up and running super fast. You don't have to worry about which distribution you're running. You don't have to worry about which version of OpenStack you're running. We are day 0 or, baked into every OpenStack distribution going back through the last number of versions. And this idea of how do we make it better? Well, again, taking our driver, making it super easy to use, and then adding additional functionality above and beyond just the base Cinder API calls that are out there. I just want to go ahead and advance the next slide. So what does this look like in practice? Well, what this looks like in practice is, on the right-hand side there, you have some SolidFire storage, and this takes another one of those diagrams from before and shows you how basically what we have is through the SolidFire volume service, that driver will go out and make calls to our storage and carve up volumes, if you will. And then on the bottom left-hand side through the Nova project or the Compute project, in this instance it's KVM, but other hypervisors are certainly supported in OpenStack, where you have a connection, an iSCSI block-based connection in this instance, between that virtual device or instance to the SolidFire storage. So we're directly mounting a block storage, iSCSI block storage device directly to the hypervisor and presenting it to the virtual machine. And we're doing, you can achieve a lot of those same things in base KVM, or base VMware vSphere or Zen server, but OpenStack is where this dynamic pools of resources and this automation magic happens, where we make these API calls, and it basically carves up the storage for us and then does the presentations for us. So that is how this automation level is achieved. Now, a lot of people say, okay, that's great. I kind of see some of the integrations, but do you play well with vendor XYZ? Or tell us about some of your customers that are out there in the market, and what are some of the use cases? Well, again, we have all of the functionality, which I think I've covered pretty in depth, but the one big thing I know I haven't covered yet is you can create snapshots, you can create clones, you can manage the SolidFire volumes directly. And what I mean by that is once SolidFire is configured within OpenStack, you actually really don't need to go into the SolidFire interface. You can control SolidFire storage completely within OpenStack. And that is a key advantage for us when it comes to, as the cloud administrator, you just set up different levels of service with our quality of service, platinum, gold, bronze, silver. kinds of level of services. And just like you would in OpenStack, say I want, a tiny compute, small compute, medium compute, you can define service levels and then present those through the OpenStack interface out to out to your customers directly. And that is our main use case for a lot of our customer success stories there. Customers such as eBay and PayPal and Internet and RicardoLibre, which I'm actually going to go into one or two of them here of exactly what they're doing and why they chose us. Take eBay, for instance. eBay, we actually are delivering a good bit of their infrastructure as a service in the development side. And what they found was they had this requirement for this ability to scale their development environments. How do I have this scale to hundreds to thousands of instances and then take them all back down? And how do I do that all within OpenStack? I don't want to have to go to my storage and provision it and then go to OpenStack and make those connections. And also, they wanted a very resilient infrastructure. And so if you'll notice on the right-hand side, we check some boxes there that we tend to call our pillars, if you will. And in this particular instance, eBay was looking for a scale-out architecture to withstand multiple concurrent failures. They wanted that API automation and that high availability that is built into OpenStack. And then another one, RicardoLibre. If you're follow the OpenStack community at all, you will know this is a very large kind of OpenStack champion from a solution standpoint and a customer standpoint in the community. And they, again, chose SolidFire for some pretty unique aspects of their workloads because, again, remember going back to my original slide, workloads drive demands. And this is both internal and external facing applications for them. And what they needed is they needed high performance and efficiency, and especially in a MongoDB environment, so database as a service, if you will. And they needed high availability, but they also needed replication. And then they wanted to be able to leverage APIs to really plug into internal monitoring tools that they had already built and developed. So on the right-hand side, we check the box of, again, the scale-out architecture was unique, the API automation, high availability, and the inline efficiency. Inline efficiency is a fancy term for disk savings. If you're creating a bunch of clones of databases, we do deduplication and compression, where we're able to increase the efficiency of the storage subsystem by being able to both serve out data to our customers, but at the same time saving data on the back end of how much data is actually physically stored on the systems. And with that, I'm going to flip it over and ask questions. Jen, what kind of questions have we had so far?
A couple, which I think you actually answered, but you can maybe add more of a full answer to it. One incoming one was, is SolidFire multi-tenant like OpenStack? And I think you did.
Oh, yeah, that's a fantastic, yes. I did talk about it somewhat, but maybe to expand on it just a little bit more, specifically in an OpenStack context. In OpenStack, you do have the concept of multi-tenancy, or really it's referred to in OpenStack as projects. And different projects can be represented by tenants. Now, that could be a workload, could be production versus development, could be different departments, could be different customers. There's many ways to slice and dice the concept of multi-tenancy, but it's really just nothing more than logical isolation of workloads in some way. And OpenStack absolutely supports that concept, and then SolidFire does as well. SolidFire uses the concept of an account. And what we actually do is we break up the storage subsystem into accounts, and then we actually identify which OpenStack tenants are owning any particular volume on our system. So it's very easy to go in and identify, because if you have hundreds of projects in OpenStack that could lead to thousands of volumes on OpenStack storage, you could very quickly have a needle in a haystack scenario of how do you find exactly which volume you want to actually look at any given time. So we provide that granularity and that connection point between OpenStack and SolidFire, and we believe that is very unique in the industry. What other questions do we have, Jen?
Someone asked if you could just clarify a little bit better when you would use Cinder versus Swift.
Yeah, so the biggest concept I would say, again, getting it down to workloads, is the idea of bursty workloads or workloads that you need to guarantee performance or provide a certain level of performance against, versus Swift or object-based workloads. They tend to be lower performance. They tend to be of a scale-out architecture where you have a lot of storage nodes and your I/O is distributed across a much greater plane so that you have a lower IOPS need typically with something like that. I hope that answers the question, but certainly if not, we can certainly follow up. I see some other questions there. Do you want me to just take one, Jen?
Yeah.
Okay.
Yeah, one more just came in.
Yes, absolutely. So it says here, we mentioned QoS, quality of service, like for instance, platinum, gold, or silver, are defined at the storage area, or at the array, How is this presented to Cinder, and could this be configured at different volume types and the same storage backend or different backends? This is actually a fantastic question. It does get a little deep in my answer, so for those kind of newer to OpenStack, I apologize. But it's the idea, if you're familiar with OpenStack and Cinder, the idea of volume types. You can think of a volume type as an offering or a template. And you were to create a platinum type, let's say, for instance, so you want to create a top level of service, you would give it or guarantee, SolidFire is the unique ability to guarantee a certain amount of both capacity and performance. So I can say, give me 100 gig, and have that 100 gig have 10,000 IOPS at a maximum, but I want to guarantee 5,000 as a minimum. So if suddenly things start going wrong in the array and it's starting to, somebody's starting to be bad, we enforce the minimums. And the minimums are the key there because the minimums are what puts those guardrails around everything else. The maximums, there are others out there that are trying to do that, but I feel like the combination of minimums and maximums are something that we do that is completely unique in the industry. So to take it back to OpenStack for a second, you create a volume type that is, say, called platinum, and then if you have multiple backend volumes, you actually name the multiple backends and then tie that. For instance, one would be called SolidFire. You would tie that platinum volume type to the SolidFire backend, so that anytime you do a platinum backend, it would define it to SolidFire and give it a certain amount of performance and capacity all in one shot. And in a multi, let's say we're doing LVM as well. LVM is kind of like test dev or a lower production kind of thing. You could create another volume type called test, and you could say it's an LVM backend and then define it from there. So volume types are the key to kind of creating these service levels, and then the service levels define which storage is used. So it's all kind of complementary in a chain, and you have to define them all, but it pops out into OpenStack very nicely into the interface. Let's see. I'm going to take another one here, Jen.
Yeah, great.
So any plans to release SolidFire version for OpenStack for Swift? There isn't at this time, and that is something that what we feel is we feel, again, we're very complementary to Swift, and we can actually talk to Swift through, actually, let me take that back. It's not just Swift. It's really anything that is Swift API compatible or actually Amazon S3 compatible as well. And again, that idea of keeping things complementary if you will, of the higher performance guaranteed workloads, that tends to be where we play and where our focus is today. But then we interact with Swift very well. So again, it's more of a complementary relationship, and no plans today that I'm aware of to go into that. I'm going to read the next one as well that just came in. So the user states, very new to OpenStack, used Hyper-V and ESXi before. How do you install a hypervisor with OpenStack? And do you install the Linux server first and then OpenStack on top? Or where exactly could you get started, if you will, with something like this? And that's actually a fantastic question. So I'll give you the short answer of how everything works together today, and then I'll give you the kind of where I would go next to learn. So when it comes to the various hypervisors that are supported, there is the concept of an OpenStack controller. Think of a controller as it is a server that sits there and controls that environment. It controls the hypervisors, which would be Nova compute instances, and it controls the block storage, in this instance, SolidFire. And so it is the traffic cop. It is the one that is taking those pools of resources and assigning them to users and then taking them back. And so you would install an OpenStack controller on top of a Linux instance. So that's when we say we're talking about installing OpenStack on top of a Linux instance. That creates a controller. And then you would need a hypervisor in addition to be a compute node. And in this instance, you could very easily do, most typically you do vSphere, KVM. KVM is probably far and away the largest hypervisor used within the OpenStack community today. And so you have this complementary aspect of you have a controller and then you have a Nova compute node as well. Now, to take it one step further though, and this is where I would say, if you want to get started, go Google DevStack, OpenStack DevStack. It is an all-in-one virtual machine that does all of this for you. It is the controller and hypervisor all in one, and it's really designed for folks that want a development, hence the name DevStack within OpenStack. But it is also a great resource that allows you to just kind of load OpenStack on your laptop. And you don't even need any hardware then to get started. Just load DevStack on your laptop. You can play around with it, and it's a good starting point. And then, of course, OpenStack.org, and then there's a documentation wiki that is out there. There's a lot of great getting started projects that are out there to kind of take you further with that. Hope that answers your question. Any other questions, Jen?
Not that I see here. Looks like you've gotten to them all. Great job.
Okay. Well, I just wanted to kind of remind everyone, so certainly, again, thank you for your time today. There is a number of attachments and links. If you don't mind, certainly there's a PDF of the slides that we used today, as well as some other case studies and some other hopefully interesting materials for you as well. And certainly, if this is of interest to you, let us know. We have the ability to do demonstrations for customers and certainly talk further about this. I'm certainly very passionate about it, and I have a number of folks on my team that we love talking to customers and really helping architect and solve problems. And so we would love to hear from you.
Great, yeah, and Aaron, if you want to announce the webinar happening, the upcoming one, in case anyone's interested, on the next slide there.
Yep, absolutely. Sorry, it wasn't going forward. There we go. That is our next event. We do have another event coming up. So there is again, kind of showing some of those partnerships, right? Red Hat and SolidFire, great partners within the OpenStack community. We have another webinar coming up next month in April. And so we would ask you to go out and reserve your spot now. If you certainly want to sign up for that, and we'll make sure you get some reminders, and we would love to see you next month. And I guess with that, Jen, I think we're ready to close it out.
Yep. Thanks, everyone, for joining. Talk to you soon.